Hey guys, so 3.1 is an introduction to working with open sentences. All right, so equations and inequalities, coming up with ordered pairs and solutions, right, and an introduction to set notation. So what we're going to do is we're going to find solutions to open sentences with two variables. Okay, so this is kind of a guess and check method type of deal, finding those solutions, and we'll learn how to actually solve for the equations in the next couple ones and graph them. Okay, so we're going to start with open sentences are just any inequality or equation. Okay, that's all it is, all it means, either one of those. An ordered pair is a solution for those open sentences in two variables. The variables are always x and y, right? You write it like this, parentheses x comma y, close parentheses. That's what an ordered pair is. Now, set notation is the way that we define these solution sets, right? So the set of all the ordered pairs that are solutions. So it could be, for an equation, it's just a set of points. Okay, so an example would be, 0, 1, or sorry, 1, -2, commas in between, -3, -8, right? And that's the set, okay? We do curly brackets on the outside of the set, okay? For an inequality, it's a little bit different, okay? The way you do set notation for an inequality is do the bracket, then you write whatever variable you have, okay? That's a bad little guy. Okay, so your variable, and then the answer. So set of all x such that x is greater than 2. Okay, for two variables, it would be the set of all x, y, such that, and then whatever you need for x, whatever you need for y. Okay, so that's what it looks like. Now, just the types of numbers, so you guys remember, right, this should be some review. Okay, natural numbers are just the counting numbers, so you start with 1 and go on to infinity, all those whole ones. Whole numbers are the same as natural numbers, but add 0 to that. Integers, same as whole numbers, but add all the negatives to all of those as well. Rational numbers can be written as a fraction. Irrational numbers cannot be written as a fraction. So any fraction or decimal that terminates or repeats is going to be rational. Anything else is going to be irrational. So irrational pretty much is pi, e, if you know what e is, all square roots, non-perfect squares, square roots, so square root of 3, square root of 8, all that type of stuff, okay? Anything else is going to be rational, okay? So, jumping into some of these examples, all right, is 2, -6 a solution to this, so plug in 2 for x, -6 for y, see if it works. 8 times 2 plus 2 times -6 equals 9. 16 minus 12 equals 9. Not true, so no. Doesn't work. Okay, we're going to find 5 solutions now for x plus 3y equals 24, so you could just plug in kind of whatever you want. Let's do the zeros. The zeros are pretty easy. So 0, if we plug in 0 for x, then y has to be 8. If you plug in 0 for y, then x has to be 6, I'm sorry. If you plug in 1 for x, then it doesn't come out right, so let's not do that. If you plug in, let's try, would be good for us. Oh, you could do negatives, so you could do, let's say you plug in 3 for x, 4 for y, right? We could do the other way around. Let's put in 9 for x and -4 for y, right? Because you have 36 minus 12. Okay, and one more you can come up with on your own. Okay, there's a whole bunch of solutions, an infinite number. Okay, they don't all have to be whole numbers or integers. Okay, so now we're just going to solve for the domain. 1, 0, -2. So start by plugging, remember domain means x. Okay, so that's what we're plugging in for the x's. So we've got 3 times 1 plus 2y equals 8. So 2y equals 5, and y equals 5 over 2. Okay, so there's 1. 3 times 0 plus 2y equals 8. All right, 2y equals 8, and y equals 4. And the third one, 3 times negative 2 plus 2y equals 8. Subtract or add the 6 over, divide by 2, and you have y equals 7. Okay, so those are the 3 solutions for the domain. Same idea over here. With number 4, you guys should try this. Plug all of those in for x to get your y's in number 4. Now, just completing these, okay, so I'll do 5, you guys could do 6. All right, so if I tell you to plug in 0 for x, so you just got to find y. So 12 divided by 3 is 4. The second one, I plug in 0 for y, you got to find x, which is 6. And the third one, plug in 4 for x, so you have 8. Subtract the 8 over, and you get 4 divided by 3, and you get 4/3. Okay, so that's how that works. It just tells you what to plug in, whether to plug in for x or y. Just remember that x comes first, then y. You guys try 6, and we'll do 7. Probably 7 and 8. 8's kind of tough. Okay, we're going to find k so that the ordered pair works. Okay, so this is an x and a y. Plug them in. Okay, so 2 plus 2 is 4, so k equals 4. Alright, 8's a little bit more tough. So we have k times 3 plus 3 times negative 3 equals 12. Okay, so I need to add the 9 over. So I've got 3k equals 21 divided by 3, and k equals 7. Okay, couple word problems. So Roberto has $22, buys some notebooks costing $2 each, some binders costing $5 each. If you spend all the money, how many of each does he buy? There's a couple possibilities here. Okay, so you've got 2n plus 5b equals 22, or 2x plus 5y. Okay, so we're going to come up with all the possibilities. Obviously, you can't buy decimal or fraction of notebooks or binders. You have to buy enough for all of them. So we also know, because this is even, right, this can't be odd, okay, because you can't add an odd and even and get an even number. Okay, so this has to be either 0 or 2 or 4. Okay, so the number of binders is either 0, 2, or 4. So let's call, so for the notebooks and binders. Right, so for binders, you can have 0 of those. If you have 0 of those, then you have 11 notebooks. If you have 2 binders, then that's $10. So you have $12 to spend on notebooks, so that gives you 6 of them. And if you have 4, you only have $2 to spend on notebooks, so you could buy 1 of them. So those are your ordered pairs, and you can obviously organize them in ordered pairs depending on how you're supposed to answer. Now lastly, 2-digit number is such that the tens digit is at least 5 more than twice the units digit. Find all positive integers with this property. Okay, so the units digit times 2 plus 5 equals tens digit. So units times 2 units plus 5 equals tens. Okay, now that's not going to help us that much, but I do know that the smallest the units digit could possibly be is 0, right? So for units, I could use 0. 1 would work because 2u plus 2 times 1 plus 5 is still a single number. 2 works, but 3 would not work because if you do 2 times 3, you get 6 plus 5 is 11. Well, 11 can't be a digit. All right, so my units have to be 0, 1, or 2. Okay, so for 0, right, if I do 2 times 0 plus 5, that's 5. So the first number that's going to work, I know, is 50. Right? Now, I also know that 60 is going to work, 70 is going to work, 80 is going to work, 90 is going to work. Why do I know that? Because it's at least 5 more than twice the units digit. Okay, so all of those work. Now working with the ones, does 51 work? No. I got to use 2 times u. 2 times 1 is 2, plus 5 is 7. So 71 is the first one that works. 81 would also work, and so would 91. And for the 2s, 2 times 2 is 4. 4 plus 5 is 9. So 92 also works. So these are all the ones that work for that satisfy.